The rapid development of the automotive industry not only brings convenience in transportation, but also causes serious air pollution. And it poses a great threat for people's health and life. The green power of international Weichai turns the whole country's expectation on an industry into the remarkable reality. In April 2011, Weichai Group won the China Industry Award. The presentation speech said, in the process of Chinese industry transitioning from manufacturing to creating, rising from the low end to the high end of the value chain, Weichai led the development with independent innovation, making outstanding contributions. By the end of 2007, the world's first powertrain product was produced in Weichai, which is a landmark industry milestone. The world does not lack enterprises dedicated to engine supply, first-class gearbox manufacturers, or parts suppliers. But it is only Weichai that integrated them into one group, owning independent technologies to put forward the new concept of the powertrain and turn it into an exclusive product. With the unique business model and brand new industrial development thinking, Weichai accelerated the development of 13 years to complete the growth that the global industrial giants needed 100 years. Weichai became the world's first and the only powertrain supplier, becoming #1 in the world for the production and sales volume of high-power, high-speed engine and #1 for the sales volume of heavy-duty transmissions. In 2000, Weichai began full implementation of the property reform. In 2002, Weichai Power Company was founded with the polymerization of high-quality assets. On March 11, 2004, Weichai Power was listed in the Hong Kong stock market, entering the international capital markets. April 30, 2007, the acquisition of Torch Sparkplug became China's first case of merger through stock exchange, as well as the first case of returning to mainland stock market from Hong Kong stock market, creating a Weichai mode for China's capital market. In January of 2009, the acquisition of Baoduin marked the implementation of Weichai's global manufacturing resources. On June 18, 2009, Shandong Heavy Industry Group completed restructuring and was established formally. Weichai stepped into a new fast track of development. On September 7, 2011, Weichai's Yangzhou Industrial Clusters was formed. With Yaxing Coach joining Weichai Group, Weichai's Yangtze River Delta strategy got its foundation in Yangzhou. Thus, Weichai had mastered the strategy of using two drive forces, product management and capital management, and the two drive forces brought Weichai into the even broader international market. Green Power International Weichai, it is a perennial power that will provide impetus for China's equipment manufacturing industry on the global stage. It will also provide the power needed in the process that China's creation becomes the lead in the future international industrial pattern, as well as the Chinese standard becomes the general global rule. Green Power International Weichai. Hello everyone, welcome to this walkthrough of Weichai Power's non-air assisted SCR after treatment system. To give you a better grasp of the knowledge of the system, I will explain the SCR system works and processes, as well as introduce the main components and their fault modes, troubleshooting, etc. To better understand the China 4 non-air assisted SCR after treatment system, let us take a look at Onboard Diagnostic System (OBD) first. OBD is mainly used for online monitoring and diagnosis of vehicle emission control. It consists of internal control strategy malfunction indicator lamp (MIL) of the engine ECU and standard OBD diagnostic interface. When the ECU monitors faults of the system, MIL or Service Diagnostic Light service will light up and save the fault information in the ECU. Through the standard OBD diagnostic interface, the maintenance personnel can use special equipment or manually read the fault information. Then, combined with the actual situation, the maintenance personnel will be able to quickly and accurately identify the fault and troubleshoot. If there is excessive nitrogen oxide in the exhaust, non-clearable code will be saved, and this code will be stored for 400 days or 9,600 engine operation hours. At the same time, following reasons will be indicated to possibly cause excessive emissions. 1. Urea exhaust. 2. Power interruption for reacting dosing. 3. Reactant with poor quality. 4. Low reactant consumption. 5. High nitrogen oxide emission for unknown reasons. Reasons for MIL to light up. 1. Emission exceeds the OBD limits. 2. Detection system fault. 3. Lack of reactant. 4. Engine is powered up but fails to start. Reasons for MIL to shut off. 1. Emission return to normal. 2. After 3 driving cycles for 24 hours. 3. Refill of the reactant. 4. After engine starts. Now that we know what OBD is, we'll take a look at the working principle and procedures of the SCR system. During the engine operation process, mixture of air and diesel will be compressed in the cylinder and generate nitrogen oxide. Urea solution with the 32.5% concentration will go through the urea tank, inlet tube, area pump, and pressure tube before going into the urea nozzle. When the pressure in the pressure tube reaches 9 plus or minus 0.5 bar, ECU will start injecting urea aqueous solution into the exhaust pipe according to the SCR tank temperature and nitrogen oxide content in the exhaust gas. Step 1. When the exhaust temperature is higher than 200 degrees Celsius, the injected urea aqueous solution will be hydrolyzed to ammonia and water. Step 2. Selective catalytic reduction. Ammonia and nitrogen oxides in the exhaust gas after hydrolysis with the help of SCR catalyst will turn into nitrogen and water, thereby avoiding pollutions and reducing emissions. SCR injection system operation process. A. Initial pressure building. After T15 is powered up, if there are no relevant electrical fault in the SCR system and the engine speed is greater than 550 RPM, the system heating will be completed. After the SCR tank temperature reaches 180 degrees Celsius and higher, the urea pump pressure will be preliminary built. Suction, filling, pressure buildup. 2. Self-inspection. During the initial pressure building process, the SCR system will calculate the buildup time and relief time after nozzle being forced open. To inspect urea pipeline, urea pump, nozzles for reverse installation, leakage, blockage, or other faults. If there are any, ECU control system will alert. Urea pump and pipeline will relieve the pressure, so that this driving cycle will not longer try to build up pressure again. If the inspection is passed, the system pressure will be completely built up. Urea pressure of that driving cycle will be maintained at approximately 9 plus or minus 0.5 bar. 3. Normal injection. This is based on exhaust temperature and working conditions, and will be different on different engines. Exhaust temperature is usually greater than at least 200 degrees Celsius. 4. Reverse suction when the power is shut down. Note, reverse suction time when power is shut down will be 90 seconds. During this, it is forbidden to turn off the vehicle power supply. When T15's power is off but the vehicle power is still on, SCR system enters the reverse suction process. Use the reverse valve to drain the fluid in the urea pump and urea tubes so as to prevent the residual urea in the pipeline to affect the system. Note, when the temperature is below negative 11 degrees Celsius, urea icing would happen. Weichai SCR system is equipped with a heating system in which urea tank is heated by cooling water, and urea pump and urea pipeline is electrically heated. This will ensure that the urea injection system could not work at low temperatures. Second, main components and their fault modes. special tool used to install and uninstall main filter cover has a width of 27 millimeters. The tightening torque is 19 Newton meters plus or minus 5 Newton meters. The bottom of the main filter urea pump should ensure to have more than 170 millimeters of removal space down from the center line of the filter for easy maintenance and replacement of the urea pump filter. Maximum average dust holding capacity of the 3-layer filter element 4G. Maximum average dust holding capacity of the high performance filter 12G. Specifications of urea pump electrical connector pin and waterproof and bonding requirements of the connectors. Pin 1, Pin 7 are vacant pins. Pin 5 is connected with urea pump heating relay. Pin 6 is connected with the after treatment main relay. Rest of the pins are connected with ECU. Connectors corresponded to Pin 1 and Pin 7 should use blind plugs to seal. Connectors corresponded to the rest of the pins should use sealing plug to seal. For waterproof purposes, 90 degrees or 180 degrees cover should be installed around the connector joint. To prevent damage to the wiring harness connector caused by vibration, harness of the connector needs to be tightened to the urea pump body with straps or other devices. The assembling and disassembling sequence of the connector. The installation position of the urea pump should be convenient for the assembling and disassembling of the urea pipeline and electrical parts. To prevent pollution to the electrical interface during assembling and disassembling of the urea pipeline, remove urea pipeline joints first when disassembling. Then remove the electrical connectors. Install electrical connectors first when assembling. Then install the urea pipeline joints. Now we shall take a look at the urea injection nozzle of the China 4 SCR system. The urea injection nozzle controlled by ECU will open to inject urea. It consists of urea pipe joint, cooling water pipe joint, insulation panels, electronic connector of injection valve and cooler body. It is fixed on the nozzle base of the exhaust pipe. When nozzles are working, the pressure in the pressure tube is maintained at around 98 bar. Recommended installation position 45 degrees to 85 degrees and 275 degrees to 315 degrees. It is prohibited to install in the angle range of 85 degrees to 275 degrees. To prevent nozzle clogging, the M6 bolts at the nozzle base should be a tightening torque of 8 Newton meters plus or minus 2 Newton meters. Assembling and disassembling sequence of the urea nozzle connector. Remove the urea pipe joints before removing electrical connectors when disassembling. When installing, install electrical connectors first before installing the urea pipe joints. Next, we're going to take a look at the urea pipeline in the China 4 SCR system. Suction line, abbreviated SL, from the urea tank to urea pump. Pressure line, abbreviated PL, from urea pump to urea injection nozzle. Return line, abbreviated BL, from urea pump to urea tank. Next, we're going to look at the sensors in the China IV SCR system. The upstream temperature sensor is used to measure the upstream exhaust gas temperature. The ambient temperature sensor is used to detect the ambient temperature when engine is operating. The nitrogen and oxygen sensor, NOx sensor, detects the NOx concentration in the exhaust after being treated. NOx sensor, CAN, will send the NOx concentration to the ECU through CAN bus, and then ECU will set up strategies for torque limit, etc., according to the content of NOx in the exhaust. NOx sensor specifications. 1. NOx sensor should be connected to T15 switch to identify ECU's electric signals. 2. NOx sensor's ECU has an operating temperature range of 40 degrees Celsius to 105 degrees Celsius. 3. Length of the harness between NOx sensor's ECU and the sensor head is 608 millimeters, plus or minus 8 millimeters. The installation location of the ambient temperature sensor should be away from heat and heavy mud-polluted area and also be free of direct sunlight. It is recommended to install it on the vehicle chassis, engine air inlet, or vehicle's mirror surfaces. It is an ordinary thermistor resistor. Next, we are going to look at the heating system in the China 4 SCR system. After ECU measures the ambient temperature, if the temperature is too low, urea pipeline and urea pump will be heated. Heating consists of electric heating and water heating. Water heating. Water heating solenoid valve. Purpose: heating the urea solution. When the urea tank temperature falls below -8 degrees Celsius and the engine coolant temperature reaches 55 degrees Celsius, ECU will open the coolant solenoid valve and hot coolant will flow through the urea tank to heat urea. Water heating solenoid valve is a normally closed solenoid valve. Solenoid valve installation. Flow direction is marked on the valve body and attention should be paid during the installation. The solenoid should be upward. Heating pipe installation. It is recommended to use EPDM tube with the inner diameter of 13 millimeters for coolant pipeline for heating. Joints are mounted on urea tank sensor assembly and coolant switch solenoid valve using clamps to fasten. Electric heating. Electric heating is controlled by a master relay and 4 control relays. Installation requirements. Heating relay must be waterproof to prevent water, oil, and other liquid into the heating relay, which would cause short circuit or open circuit. Heating relay should be well protected on the vehicle to prevent external shocks that would lead to poor contact or even falling off. accelerator pedal signal. Accelerator pedal signal is the voltage signal between the slide rheostat split end in the measuring pedal and the ground terminal. Signal 1 is twice as strong as Signal 2. The inspection that Bosch non-air assisted after treatment performances on heating resistor wire is carried out through the opening and closing of 4 main relays and the measurement of feedback voltage. Shut down the main relay and auxiliary relay and see if the feedback signal has high electricity level. If so, it means that the corresponding heating resistance wire is short-circuited to the power. Open the main relay and shut down the auxiliary relay and see if the feedback signal has low electricity level. If so, it means that the corresponding heating resistance wire is short-circuited to the ground. Open the main relay and open the auxiliary relay in proper order and see if the feedback signal has high electricity level. If so, it means that the corresponding heating resistance wire is open-circuited to the ground. A45 is the positive terminal of the power supply. A35 outputs PWM signal to control the electronically controlled vicious fan. A45 and A15 control electromagnetic fan relay 1, medium speed. A60 and A34 control electromagnetic fan relay 1, high speed. Installation differences with China 3 version. China 3 ECU EDC7 requires oil cooling for ECU, while China 4 version EDC17 does not. Also, the installation location is more flexible. Next, we are going to look at the SCR tank in the China 4 SCR system. It offers the reaction environment for exhaust and urea, as well as to provide catalytic reagents. At the same time, it also plays the role of silencer. SCR tank consists of catalyst, carrier, and package. According to vehicles for different applications and engines of different displacement, the dimensions of carrier and package are different. Mixture of exhaust and ammonia will enter the SCR tank through the exhaust pipe and reacts in the pores of the carrier and turns into non-toxic nitrogen and water. The catalyst works in the temperature range of 200 degrees Celsius to 500 degrees Celsius. Low temperature will lead to poor catalytic activity, which will result in low nitrogen oxide reaction efficiency. High temperature will cause cracking of the catalyst. Since the chemical reaction in the SCR tank depends on the temperature, therefore it should be installed as close to the engine as possible to ensure that the internal temperature is as high as of the exhaust temperature. If the exhaust pipe length exceeds 2.5 meters, insulation measures are recommended. Next, we are going to introduce you to the diagnostic tool, Weichai Diagsmart. Weichai Diagsmart is a comprehensive after-sales service tool jointly developed by Weichai Customer Service Center and Weichai Electronical Control Institute. It consists of the software that can be installed on PC, mobile phones, and tablets, and a Wi-Fi adapter. Diagsmart can perform fault diagnosis, vehicle performance calibration, remote ECU data management, repair help, diagnostic reporting, and other functions. It can be applied on all current Weichai electronically controlled engines and can test EDC7, EDC17, WISE, EGC4, etc. Through the Maintenance Help interface, we can get access to repair manuals and flash code tablets of Weichai China 3 and 4 engines, among other things. Through the Rapid Diagnostic interface, we can monitor the fault-related data streams according to different engine faults. Through Diagnostic Report interface, we can check out our previous maintenance diagnostic reports. These two features will be implemented in subsequent editions. Now let us find out how to use Weichai Diagsmart. The adapter must first connect to the network to verify the legitimacy before pairing with PC software. First, open Weichai Diagsmart software and log into the System Configuration interface. Next to the Register button, there is an input box. Type device's SSID, which is marked on the device label, into the input box and click the Register button. If the adapter is Weichai's legitimate product, the registration would be successful. And from now on, the PC software will no longer need to register online to pair with the adapter. Then we can insert the adapter into the OBD2 16-pin diagnostic interface that the vehicle reserves and turn the key switch. The power indicator light at the bottom of the adapter will light up. At this point, the wireless network display area on the PC will show a Wi-Fi hotspot with the same SSID. Click it to complete the connection between PC and wireless adapter. Select the engine controller and enter the diesel engine controller list of Weichai Diagsmart. Here we're going to use Weichai China 4 engine controller as an example to demonstrate how to use Diagsmart. Click on Weichai China 4 to get access to the engine service interface. First, we are going to see how to read the engine controller information. Click on the Controller Information button on the left to enter the Controller Information display interface. Then click on the Read Controller Information button at the bottom right of the screen. This way, the controller information of the China 4 engine has been read. Click on the Fault Code button in the left slit to enter fault code related information interface. Then we can see that Weichai Diagsmart supports reading, clearing fault codes, reading frozen frame, and other functions. First, we click on the Read Fault Codes button, and engine fault information will be read. Next, select the fault code of the frozen frame that we wish to know and click on the Frozen Frame button. The frozen frame information of the corresponding fault will be read. If we click the Clear Fault Code button after we solve the problem, the fault code will be cleared. Click on the data stream in the left list to enter the data monitoring interface. Select the variables we need to monitor in the variable monitoring section. Here we're going to choose to monitor all the variables. Click on the Start Monitoring button and the variables we choose will be displayed on the screen. We can flip to see other variables. Click on the Stop Monitoring button after the variable measurement is completed. Click on the Actuator Test in the left list to enter the Actuator Switch Test interface. At this point, you can click on each actuator's corresponding Open and Close button to enter or close the actuator. By observing the sound and light of each actuator, you can decide if there's damages to the actuators. Click on the Vehicle Calibration button on the left to enter the Vehicle Function Calibration interface. After calibrating the vehicles, click Generate.ini file to save the configurations. At this point, we can choose to flash the ini files. Click Flash to complete the function calibration and flashing. This process would take about 2 minutes. When flashing is completed, it will be shown in the operating area. Now we are going to introduce how to investigate the faults in the non-air assisted SCR system. Third, investigation. Before explaining, let's first review the theoretical knowledges. The chemistry used in the process of reducing NOx in the exhaust through SCR is as follows. The aqueous area solution is hydrolyzed and turned into ammonia at high temperature. At high temperature, with catalyst, ammonia will react with NOx and eventually turn NOx into non-toxic nitrogen. Thereby reducing NOx emissions. Here is the structure diagram of the SCR system. The SCR system can inject the right amount of urea at the right time. This system mainly consists of 3 parts: urea system, sensors, and heating systems. The urea system includes urea tank, urea pump, urea injection nozzle, SCR box, and urea pipeline. Sensors include urea tank level and temperature sensor, urea pump pressure sensor, upstream exhaust temperature sensor, nitrogen oxide sensor, and ambient temperature sensor. The heating system includes water heating of the urea tank and electrical heating of the urea pipeline and urea pump. All of these sensors and actuators are controlled by EDC 17. The 5 conditions that the urea pump needs to build up pressure normally, according to time priority, are: 1. When T15 is powered, ECU detects the existence of SCR sensor-related, actuator-related, and other electrical faults. 2. Whether the engine is started or not, if the engine speed is greater than 550 RPM. 3. If the SCR system heating is completed, judged by the urea tank temperature and ambient temperature. 4. If the upstream exhaust temperature reaches above 180 degrees Celsius. 5. During the pressure buildup test, if there are pipeline, suction pipe, return pipe, pressure pipe, urea pump and nozzle clogging leakage to other faults. For the above 5 conditions, each condition is the premise of the next condition. If the first 4 conditions are not met, ECU will not testing for the 5th condition. That means even if there is clogging or leakage, ECU will not be able to detect them. Chapter 2: Investigation and Troubleshooting. SCR after-treatment faults could be divided into 2 main categories: components faults and system faults. Component faults. ECU reported a clear fault of parts such as pins or faults related. For example, urea pump motor open, urea pipe, pump to tank, heating resistance wire open circuit fault. Features such as faults. Since ECU clearly determined the point of fault, such faults are easier to troubleshoot. Investigation methods. 1. Use the diagnostic equipment to read engine fault description, open circuit of the urea pump motor. 2. Follow the fault description to find out the component with fault, urea pump motor. 3. Follow the sequence of motor-related wirings to connectors to urea pump to investigate. System faults. It is very difficult for ECU to determine the specific component with fault. ECU will only be able to identify abnormal physical parameters of the SCR system, such as urea pressure buildup error ECU report or high urea consumption customer feedback. Regarding these faults, ECU will not report the specific failed component or sometimes even will not be able to detect faults at all. Investigation methods. 1. Figure out the system with fault using solid theoretical knowledge, urea pressure buildup error to pressure building system. 2. Analyze the fault principle and inspect the parts that most likely have faults. Urea pipeline. 3. Inspect all the parts involved in the system according to the principle of from simple to difficult: urea pipeline, pipe joint, injection nozzle, urea pump. In contrast, the component fault is easier to find. On the basis of the understanding the working principle and circuit wirings of the components, with the help of diagnostic equipments, fault causes can usually be found. System fault investigation relies on solid theoretical knowledge, and it needs maintenance personnel to have certain level of analysis and problem-solving capabilities. As it has rather high requirement on personal capability, we will focus more on the investigation ideas of how to find system faults. Case 1. OBD light lights up during driving and gives the alert of SCR urea pressure buildup error. Before solving this problem, please think about these 2 questions first. Question 1. Which system does this fault belong to? What kind of parts are there in this system? Question 2. Are there chances that the electrical fault is caused by urea pump motor open circuit or short circuit between urea nozzle drive end and power? Analysis. The description shows that the SCR system has entered pressure buildup test procedure, which means 4 conditions out of 5 have been met. So basically there is no chance for urea pump motor open circuit, short circuit between urea nozzle drive end and power, or similar types of electrical faults. Otherwise, it wouldn't reach the pressure buildup test stage. Investigation methods. 1. This fault belongs to pressure buildup system, so make a list of all related parts. Urea pipeline, including the part in the urea tank. Pipe joint, urea pump and injection nozzle. 2. Analysis of fault principles. Generally, the reason would be improperly urea suction. So we need to first check if the suction pipes are reversed, leaking or blocked. 3. Follow the principle of from simple to difficult. Investigate on other urea pipes, to filter element, to pipe joint, to injection nozzle to urea pump one by one. The whole process will be using diagnostic equipment and necessary measures will be taken to meet all 5 conditions for urea pressure buildup. 4. Failure elimination confirmation. If urea pressure is able to maintain at 9 bar for over 5 minutes, it means that the fault is eliminated. Case 2. Feedback says that urea consumption is high and there are no SCR-related faults reporting by ECU. Similarly, let us think about 2 questions before we try to tackle this problem. Question 1. What do we get from urea consumption is high? Question 2. What system does this fault belong to, and what is the most likely cause of the malfunction? Analysis. From this information, we can at least get 2 very useful hints. 1. SCR system is able to enter the urea injection stage, so that means the 5 conditions for urea pressure buildup have all been met. Therefore, there are no electrical faults. 2. ECU hasn't detected any faults, so it indicates that this fault belongs to minor mechanical malfunction, which means it will not severely affect urea pressure buildup. Investigation methods. 1. Analyze the reasons for the fault, and we are most likely to find 2 causes: urea leakage and worn nozzles. 2. Check for leakage traces on the suction pipe, pressure pipe, and around urea pump. 3. For worn nozzles, take measures to meet the 5 conditions for the urea pressure buildup. Take the nozzle out of the exhaust pipe to check for drops of urea. There are a lot of SCR faults like this, so in addition to the solid theoretical knowledge, service personnel also need to have high levels of analyzing and thinking capabilities. In the troubleshooting training, it is crucial that we learn how to understand the troubleshooting ideas, for the ideas would be the same in the later investigations. Following are several interesting examples for all of you. Low actual average conversion efficiency of SCR. Too much high urea injection control pressure controlled by SCR urea measurement. Urea pump pressure is lower than the lower limit. Due to the limited time, we won't be able to talk about all the faults here. Please try to understand. We will gradually enrich the training materials later. Usage and maintenance. According to the current China 4 regulations for OBD, when the urea tank level is below 10% of the volume, corresponding dashboard warning light is going to flash. At this point, timely fill urea solution. Urea solution needs to be purchased from authorized retailers or professional manufacturers. To prevent engine limiting torque due to lack of urea, user can keep certain amount of urea solution on standby. It is prohibited to use unauthorized, non-standard urea solution or other alternative liquids. Impurities and metal ions will affect the system operating ability and shorten the system life. Otherwise, resulting losses will not be covered in the warranty. When starting the diesel engine, after engine speed and exhaust gas temperature reach default values, the system will begin working. After the engine shuts down, the system will go into the suction procedure. It will empty the urea solution in the system and will last 90 seconds. Do not disconnect the main power switch when the system is still working. After the system is normally shut down, after the entire suction process is completed, the engine can be shut down for 4 months without disassembling and preserve